Hello guys, in this class we'll discuss some advanced problems on binomial theorem. So let us just start quickly. First one, if f of x is summation r 0 to 50, 50 cr sine 2rx by r 0 to 50, 50 cr cos 2rx, then find f of pi by 200. You can pause, give it a try. Let's start discussion guys. The answer for this problem will be 1. F of x will come out to be tan 50x. Let us see how. So summation r 0 to 50, 50 cr sine 2rx, let us refer to this thing as I. Summation r 0 to 50, 50 cr cos 2rx, let us refer to this thing as j. So if I say summation r 0 to 50, 50 cr cis 2rx, complex number is here, cis 2rx, what we get? We get this thing will become like j and this thing will become I. So we get j plus iota I is summation r 0 to 50, 50 cr. We get e power iota 2rx, which you can also write as e iota 2x raised to power r. And you see this thing will be nothing but 1 plus e iota 2rx whole raised to power 50. And if you remember, 1 plus cis theta will be 2 cos theta by 2 cis theta by 2. So you get 2 cos x e iota x whole raised to power 50. So you get 2 cos x raised to power 50 and this will become e iota 50x or cis 50x. So you get cos 50x plus iota sine 50x. Now if you compare the real and imaginary parts, so j will be 2 cos x raised to power 50 cos 50x. I will be 2 cos x raised to power 50 sine 50x. When you divide them, you get fx will be tan 50x. So f of pi by 200 will just be tan pi by 4, that will be 1. That's all. Next guys, saying n is summation r1 to 15 minus 1 bar r plus 1 15 cr into 17r c15. Then digit at tens place of n is. This is a very good problem. You can give it a try. Let us start discussion guys. The answer for this problem is 9. See, first of all, just write the series that we have to find out. They'll give you like idea how do we start the problem then. Just put R as 1, you get 15C1, 17C15. Put R as 2, we get 15C2, 34C15. Put R as 3, get 15C3, 51C15, and so on. You see, this thing is constant here. Now, if you remember, I have given you a series of this kind. So we make use of this term. We say coefficient of x power 15 in. I took negative outside. First I'm as 15C0. Here there will be no x power 15. Minus 15C1, 1 plus x power 17. So this minus minus become plus here. And the coefficient of x power 15 here will be 17C15 only, no? Next will be 15C2, 1 plus x power 17 square. So that you get 34C15 when we find coefficient of x power 15 here. And keep on doing that till 15C15, 1 plus x power 17 whole raised to power 15. So if you see this thing, this will be nothing but expansion of 1 minus 1 plus x power 17 whole raised to power 15. And when you simplify this thing, when you expand 1 plus x power 17 inside, the first term will be 1, get cancelled out. You will get minus 17x minus 17c2x square minus 17c3x cube and so on, whole raised to power 15. And if you see coefficient of x power 15 here, basically what you can do is take x outside. So x power 15 will be outside. So from inside we just need the constant. And the constant will just be the first term only raised to power 15. So you'll get finally 17 power 15 will be coefficient of x power 15 here. And then they're asking the digit at tens place of n. And how do you find the digit at tens place of n? See, 17 power 15 you can write as 17 into 289 power 7. 17 square is 289. Then 289 again write as minus 1 plus 290 is to power 7. When you expand, you get minus 1 plus 7c1 290 plus. Now everything else will have two zeros at the end, so I'll write as 100k. Last two will be zeros in all the terms after that because 290 square will have two zeros in all the terms also. When you solve this thing, get 2029 plus 100k into 17. Then you multiply here, you get 34493 plus 1700k. So here last two will be zeros only. So last two digits will be 93. The unit, so the tens place will be 9. I hope it is clear, guys. Next. I think 5 raised to power 5 raised to power 5 raised to power 5 up to 24 times. Divide by 24. Find the remainder. I'll give it a try. Let us start discussion, guys. You see, 5 raised to power 5 raised to power, no matter what is that, can I say this number will come out to be an odd number? Because if 5 raised to power 5, no matter how many times, odd number raised to power odd number will always be odd number only. So this term will just be an odd number. So 5 power 2k plus 1, which you can write as 25 power k into 5 by 24. Now remainder of 25 with 24 is 1. So 1 power k into 5 by 24. So finally answer will just be 5. So it might look a typical problem, but it's eventually very easy. Next one, guys. Summation r 1 to n minus 1 power r minus 1 into 1 plus 1 by 2 plus 1 by 3 up to 1 by r into NCR. This is a bit typical problem. You can give it a try, guys. Let us start discussion. First of all, this 1 plus 1 by 2 plus 1 by 3 up to 1 by r. Can I write it like this way? Integration 0 to 1, 1 plus x square up to x power r minus 1. If you remember, integral of 0 to 1 x power n dx was 1 by n plus 1. So using that here, you get this thing to be 1 plus x square up to x power r minus 1. Now for this, you can use the formula of sum of GP, you get 1 minus x power r by 1 minus x. So this thing we can write this way also. Okay, now we have this outside. Now these are independent here of x, so they are constant. So even if you take them inside the integral, it won't matter. So we can write this whole thing as 0 to 1 summation r 1 to n minus 1 power r minus 1. This thing 1 minus x power r by 1 minus x NCR dx. Okay, these are x here. Now this minus 1 power r minus 1 into 1 into NCR. This will be one term when we like expand this bracket. And next term will be minus 1 power r minus 1 x power r into NCR. Let us solve them separately. So we have summation r 1 to n minus 1 power r minus 1 into NCR. You will see this will be like this. If I take a negative outside, so get summation r 0 to n NCR minus 1 power r, and if you start from 0, first term will be missing, so subtract 1. So finally this thing will just come out to be 1 only. And if we have this x power r thing, so minus 1 power r minus 1 NCR x power r, here also again minus outside, we get summation r 0 to n NCR minus x power r minus 1 because first term was missing. So this will become 1 minus x power n minus 1 negative outside. So this will be 1 minus x power n. Okay, so these two terms, so will come out to be first will be 1, next will be minus of 1 minus, basically this numerator will just be this minus this. So finally you get this 0 to 1, 1 minus 1 minus 1 minus x power n divided by 1 minus x dx. So 1 cancel, 1 minus x cancel, you get 0 to 1, 1 minus x power n minus 1 dx, which you can directly integrate and you get final answer to be 1 by n. So this is a problem with the help of integration. We can solve it easily. Next problem, guys. 100C0, 100C2 plus 100C2, 100C4 plus 100C4, 100C6 up to 100C98, 100C100. Can give this a try, guys. Let us start discussion. Can I say we get this 100C0, 100C2, 100C4, 100C like this even terms when you do 1 plus x power 100 and 1 minus x power 100 and add them, divide by 2. We get only the even terms 100C0, 100C2 x square, 100C4 x power 4 and so on. Now replace x by 1 by x. You get 1 plus x power 100. Here you get 1 minus x power 100. Basically, it will be same only. And this side, like that series, will get reversed. The powers of x will get reversed. So this x power 100 will become 1 by x power 100. When you take LCM, you go with this thing. So the series will come out to be 100C100 plus 100C98 x square plus 100C96 x power 4 and so on. Now, if you want 100C0 and 100C2, see 100C0 and 100C2. When you multiply these two, you get x power 98. Next, 100C2, 100C4, 100C2, 100C4. Again, you get x power 98. So the given series will be nothing but coefficient of x power 98 in the product of these two. So if you multiply these two, you get this is only 1 plus x power 100 plus 1 minus x power 100 whole square. 1 by 4 outside. Just use a plus b whole square, you get a square plus b square plus 2ab. So 1 plus x power 200 plus 1 minus x power 200 plus 2 times 1 minus x power x square power 100. So coefficient of x power 98 here will be 200C98. Here also 200C98. And I think here will be 100C49 negative. So final answer is 200C98 minus 100C49 by 2. So this is one of the way you can do it in another way also, but this I feel is easy. Okay, guys, next. Coefficient of term independent of x in expansion of x plus 1 by x power 2 by 3 minus x power 1 by 3 plus 1 minus x minus 1 by x minus square root x whole power 10. This is a PYQ. It was asking some J mains or advanced, I don't remember. But it's a PYQ. Can give it a try, guys. Okay, let us start discussion now. The answer is 210. So see, x plus 1 you can factorize as x power 1 by 3 plus 1, x power 2 by 3 minus x power 1 by 3 plus 1. Basically using AQ plus BQ identity. And this x minus 1 here, x minus 1, we can write as root x plus 1, root x minus 1. So eventually this will come out to be just x power 1 by 3 plus 1. And this second thing will come out to be root x plus 1 by root x. When you simplify further, you get x power 1 by 3 minus x power minus x power minus 1 by 2 whole power 10. We want independent of x, that means constant term. So at the general term, find the power of x equate to 0. We get r as 4. Put it here, you get 10c4 minus 1 power minus 2. So just put 10c4, that is 210. Next, guys. We have a double summation problem, but this is different from what we have discussed in the class. It is summation S1 to N in summation R0 to S NCS into SCR. You can give it a try. Let us start discussion now. The final answer is just 3 power n minus 1. This is a very easy problem. See, just this summation you keep outside, and this summation if you take, this summation is on R. So NCS will be constant here. You can just keep it outside. And this summation R is 0 to S. Put it on this. You get SC0 plus SC1 plus SC2 up to SCS, which will be nothing but 2 power S. So get NCS 2 power S summation S1 to N, that will be nothing but 1 plus 2 power N minus NC0 2 power 0. Basically, the first term is missing when you put 0. So this is nothing but 3 power N minus 1. That's all. Next. A good problem again, limit n tends to infinity p0 summation p0 to n ncp by n power p into p plus 4 is equal to k minus 1 into k minus e, then the value of k is. Let us see this, guys. First of all, again, a very good problem here. This p plus 4 I can write as 0 to 1 integral x power p plus 3 dx. Can do this thing. Again, all these things are constant. You can take it inside, no problem. And x power p plus 3, what I'll do is I split here, x cube and x power p. This x power p I combine with n power p gets summation p0 to n ncp x by n power p. And if you see this thing, it is nothing but 1 plus x by n whole raised to power n. And if you see this, there is limit n tends to infinity. If you see limit n tends to infinity, it will become 1 power infinity form. So when you solve that, it will come out to be e power x only. You can solve 1 power infinity form in the power of e fx minus 1 into gx. So we see n will get cancelled out, 1 will get cancelled out, you get e power x only. So this is x here. So 0 to 1 x cube e power x dx. When you solve this integral, you get 6 minus 2e. You can again solve this using the successive integration. And then 6 minus 2e you compare with k minus 1 into k minus e. Finally get k as 3 or e minus 2. I think it was an integer type problem, so the answer we can say will be 3 then. Otherwise both will work. Okay, next problem, guys. This is a very good problem. 1 minus x cube raised to power 2014 is summation r0 to 2014 br 1 minus x power 6042 minus 2r into x power r. They're asking summation r0 to 2014 br is equal to n. And the last digit of n is. You can pause and give it a try. Let us start this vision, guys. The answer for this problem is 6, and let us see how. First of all, just divide both sides by 1 minus x power 6042. So if you divide left side by 1 minus x power 6042, it will become this thing as it is, 1 minus x cube, and this will become 1 minus x whole cube whole power 2014. And on the right side, this thing will go, and you get from here you get 1 minus x power minus 2r, which you can write as br as it is, x by 1 minus x whole square raised to power r. So we get this thing. Now to find summation r0 to 2014 br, summation r0 to 2014 br, I just put this thing as 1. Because if this thing is 1, you get just this thing only then, no? So if I put x over 1 minus x square as equal to 1, so you get x equal to 1 plus x square minus 2x. Divide by x both side, you get basically get x plus 1 by x minus 2, which is on this side, you get x plus 1 by x as 3. On the left side, we have 1 minus x cube by 1 minus x whole cube. Let's try to solve this thing. Get 1 plus x square by 1 minus x whole square. No, this 1 minus x get cancelled out one time. And this 1 minus x whole square, we can see just x only from here. So get 1 plus x square by x. So when you split that, you get 1 plus 1 by x. X plus 1 by x is 3, so this will be 4. So when you put x over 1 minus x whole square as 1, So this will become 1 and this thing will become 4. So we get 4 power 2014 equal to summation R0 to 2014 BR. And you want the last digit of 4 power 2014, cyclic order of power of 4. So basically, power of 4, if it is 1, you get 4. Power 2, we get 6. Like 4 power 1 will give you last digit 4. 4 power 2 will give you 6. Then you will see 4 cube will again give you 4. 4 power 4 will again give you 6. So the same order will keep on going 4, 6, 4, 6, 4, 6, and so on. So all the even powers will give you 6. So 4 power 2014, last digit will be 6. I hope it is clear, guys. Next. In the expansion of a plus b plus c plus d whole raised to power 6, find the sum of coefficients of terms containing a, b. So like those terms which contains both a and b. And second, containing a, b, c, d. Those terms which have all a, b, c, d. We have discussed similar kind of problem, but this is one step higher. Now, you can give it a try, guys. Let us start discussion. So first answer is 2702 and second is 1560. We can use set theory here. How do you use set theory? First, when you want containing the terms A and B, I'll define an event A, capital A is an event which is the terms not containing A. So event A means those terms which does not contain A. Similarly, for BCD also will define the events. So that means we're looking for the sum of coefficient of terms. A naught will mean that it will contain A. If A was not containing A, so A naught will become which are containing A, and B naught will become which are containing B, and intersection. That means sum of coefficient of terms which contains both A and B. And using set theory, we can say be n of U minus n of A union B. So it will be n of U minus n of A minus n of B plus n of A intersection B. So n of U means total sum of all the terms. That will be like sum of coefficient of all the terms. That will just be 4 power 6. Put all of them 1. N of A means should not contain A. So put A as 0, rest all 1. So 3 power 6. N of B, put B as 0, all other A, 3 power 6. Plus N of A intersection B. That means A should not be there, B should not be there. So put A and B as 0, rest all 1, you get 2 power 6. So 4 power 6 minus 2 power 6 minus 3, 4 power 6 minus 3 power 6 minus 3 power 6 plus 2 power 6. When you solve, you get 2702. And when they say containing ABCD, then we use N of A naught intersection B naught intersection C naught intersection D naught. There will be N of U minus N of A union B union C union D. Same set theory you can use. Finally get 1560. You can refer to the set theory formula for this. Next, guys. Next is summation R0 to summation R2020 to infinity 1 by RC2020. Fractional part of this is K. The value of 1 by 300 K step. So good problem, guys. Give it a try. The answer for this problem is 6. One way is like we can write 1 by NCK plus 1 as K plus 1 by K, 1 by N minus 1 CK minus 1 by NCK. But mugging this will be difficult. So let us see how else we can see this problem. We have one more way we can do this thing. We have 1 by RC2020, which will become R factorial 2020 factorial R minus 2020 factorial. When you simplify this thing, 2020 factorial will be as it is, and we get R into R minus 1, R minus 2, up to R minus 2019. Okay, now we put summation over this thing. So we have to find summation R from 2020 to infinity of this thing. Now these kind of things we do in sequence and series. What we can do is see the difference of first and last term is 2019. So I'll just multiply divide by 2019. So 2020 factorial outside, 2019 outside. We can write this as summation r 2020 to infinity. 2019 I'll write as r minus 2019, and the denominator will be same. Now you split them, so 2020 factorial by 2019 summation r 2020 to infinity. When you split them, you get 1 by r minus 1. This right directly here. One time you get all the terms here. Uh, 1 by this thing. Next time will be minus of 1 by all these terms. Last will be now r minus 2018. Now when you put summation over this thing, you will get a telescopic series where all the terms will get cancelled out. Remaining will be first and last. So first will be when you put r as 2020 here. When you put r as 2020, I think you'll get 2019 factorial. When I put r as 2020, you get 1, 2, 3 up to 2019. So it'll be 1029 factorial, and last will be 1 by infinity, which will just be 0. So finally get 2020 by 2019. This 2020 factorial, 2019 factorial, you get 2020. Now the fractional part of this will just be, so k is fractional part of that, 2020 by 2019. So just be 1 by 2019. Okay, and finally they're asking what? Step of 1 by 300k. So step of 1 by 300k, so there will be 2019 by 300 step. You can see this is about to be 6 only. 1800 by 300 would have been 6, 2100 by 300 is 7. So this number lie between 6 to 7. So step will be 6 only here. So this method will be fine, guys. Next. A last problem for now. Summation k 0 to 9 minus 1 power k, 3 power 9 minus k, 20c k into 20 minus k c 9 minus k into 2 power minus 9 is 20 cr, when the value of r is. It looks very typical, but I think it come out to be easy only. Can give it a try. Let us start discussion, guys. See what you can do here. We have 3 power 9 and 2 power minus 9. Just take this outside. You get 3 by 2 raised to power 9. Summation k 0 to 9. This 20c k and minus 1 power k, 3 power minus k will become minus 1 by 3 power k. And next, this is 20 minus k c 9 minus k. We can also write as 20 minus k c 11. So this finally just be k 0 to 9, 20ck minus 1 by 3 power k, 20 minus kc 11. This will be nothing but coefficient of x power 11. Change the color of this thing. So this will be nothing but, so this 3 by 2 power 9 outside, and this thing will be nothing but, again focus on this thing. Coefficient of x power 11 in 1 plus x minus 1 by 3 raised to power 20. Like this series will be nothing but coefficient of x power 11 in 1 plus x minus 1 by 3 raised to power 20. We have done similar kind of problem, guys. You can refer them. Like when you expand this series and see the coefficient of x power 11, you get this thing only. So this will become 2 by 3 plus x raised to power 20. Coefficient of x power 11 here will be 20c11 into 2 by 3 power 9. So this and this get cancelled out. You directly get 20c11. So R will be 11 or 9 also, no? But on the option we have 11 only. Because 20c11 and 20c9 would have been same also. Okay, guys, so that's all for now. Bye.